let's look again at this integral that we've just done to find the area underneath this curve. So we've now found that that area is 3. And we might well not be interested in that area. Let's say this is voltage. So to continue what we're talking about, Howard, voltage, and this was time along here, then what would this area represent under here? Voltage times time, volt-seconds. But what we might be interested in is not what is the area underneath this curve, but what during this period of oscillation of this, say, AC supply, what's the average voltage? We might be far more interested in that. What's the average voltage during this period? So what we do is we use integration to find the area, and then we divide that area by this distance here to get the average value, because of what we were talking about in the drill at the beginning of today. If this area, if this was 3, so the same area, then we could replace this curve, this thing here, we could replace that by a rectangle with the same area, with the base the same, pi over 2, and in this case, that point x would be the average value. You see that? Would be the average voltage. So how do we use integration to find the average value? What we do is we use this formula. And all that's saying is, to find the average value, and this means average, this bar above the function, so fx bar, how do I find the average value? I integrate between the limits I'm interested in, a and b, and then I divide by those limits, b minus a, and that will give me the average value. And it's called the mean value formula, but it just comes from that idea of finding the average value by dividing the area by the bottom distance, if we consider it as being like a rectangle here. So this will be b, and this will be a. So what's the distance between a and b? b minus a. And that gives us this formula here, the average value formula. So for example, for our function, we now know the area is 3 from what we did previously. We know the limit is pi over 2. So what do I do to get the average value between 0 and pi over 2? I take my area and divide by pi over 2. Dividing by pi over 2 is the same as multiplying by 2 over pi. So actually the answer is 6 over pi. And if we wanted to know what that was as a decimal and round it, I would work out what 6 divided by pi was. But that's an exact answer, 6 over pi. So I could well leave it like that. And if that was a voltage against time, I could say between 0 and pi over 2 seconds, which is around about 1 point something seconds, the average voltage would be 6 over pi, which is just less than 3 volts.